Hello everyone, I'm Hari, one of the TAs for ece351. This week in our tutorial session, we are going to be looking deeper into program understanding using object diagrams. This is section 2.2 of the class notes. I have this open in my iPad screen here, and this is in page 15. In this week's lecture, I believe Professor Ari did Harry Potter's origin story. In the lectures, you went over this program and two object diagrams at two particular lines of the program, particularly at line 16 and line 90. In this tutorial, we are going to look at a larger example, Superman's origin story. After that, we look at one example for aliasing, which is where the wild things are. And finally, we will look at an example with a final, with final variables, the keyword final. Okay. So let's get started with Superman's origin story. Okay. What I'm going to do is I'm going to look at this program and I'm going to draw the object diagram on my right. And then we will look at the solutions and we'll see that it matches the solution. Okay, so what is Superman's origin story? Well, this is we are writing a code to describe what happened when Superman was born, or the events that happened right after Superman was born. So here we have a class Superman origin story, and it has a function called main, and then there is a class person, and there is a constructor for the person. This is line 42. Okay, and if you look at the main, what it will do is it will first create a planet, name it Krypton, then you create Earth, then you create Superman's father and mother, and then you connect them as spouse. Then you create Superman. His original name was Kal-El. Then you destroy Krypton. So you set Krypton to null, his father and mother to null. And finally, you set Superman's planet to Earth. Of course, when he came to Earth, he had a couple of he had a new father and a new mother, and he changed his name. Okay. After when he came of age, he was called Superman. Okay, so this is, as everybody knows, this is what happened to Superman. And now we are just, we are just going to write that down as code. Okay, so in the code, there are specific points where we have to draw the object diagram. In this case, the first point is line 12. So the first thing that you do is you mark the PC. So you say PC is line 12. And when you're in line 12, you are in the function main. And when you start executing main, what the compiler does is it will look at what the local variables are for this function, and then allocate them on the stack. So what are the local variables? The first thing would be Krypton. I'm not going to write the whole variable name. I'm just going to call it K. And then you have planet Earth. I'm not even going to name the type here. Just going to write the variable name. And there is a person, jar L. There is Lara. There is Carl L. So even though we are looking at line 12, when the compiler does its allocations, it will look at all local variables. So you have to go deeper and you have to say, you have Jonathan Kent, you have Martha Kent, you have Clark Kent, and finally you have Superman. Okay, so this is what the compiler would do. It will, when it starts executing main, it will look at all its local variables and allocate them on the stack. Okay, and now what happens at line 12? What happens before line 12? Let's see here. The first thing that we do is at line, oops. So would we go back here? Clear. So we are at line 4. When we are at line 4, we create a new planet. So planet, I'm just going to call it planet 1. Is going to be an object in the heap, which is shown on the right side. It is the object is allocated each time you call new. At line 4, what you do is you create a new planet and make a pointer to Krypton from it. The next thing you do is create Earth. Let's just call it planet 2. And you have a pointer here. And the next part is interesting. Sorry. Yeah. Yeah. The next part is interesting. You create a person, Joe L, and the person constructor takes 3 arguments or 4 arguments. Let's look at what they are. So class person, we have father, mother, spouse, and the planet. And when we created Jor Al, Jor Al, the first 3 fields are none, only the planet is scripted. Okay, so let's create such a person. So person 1, and the planet is P1, and it was assigned Joral. And the next step in the program, this is line 8, is to create another person for Lara, person 2, and here now we have Lara's spouse, which is pointing to jar L, and Lara's planet, which is pointing to Krypton. Okay, and we make now we have we have to connect Lara to person 2. The next thing that we do is we assign your L spouse to Lara. So we make another arrow. This is also spouse. Okay, good. So this would be this would be line 9, and at line 11 you also have Carl L being born. So that would be person 3, and so Carl L already has Jor-El as his father. This would be father. Laura as his mother. And Krypton as his planet. Okay. And in the stack, this is stored, pointer is stored in Carl L. Okay. So this is what you would get in line 12. Looks a little bit hairy, but it's all very simple. Okay. Now, next is the interesting part. What happens when you destroy planet Krypton? So the first thing, the next line of the program sets Krypton to null. Oops. Sets Krypton to null, Jor-El to null, and Lara to null. And what it would look like is you get rid of Krypton. You get rid of Jor-El, remove this line, and you remove this line as well. Okay. And okay, right now, even if you run garbage collection, technically it won't remove anything. So I'm not going to delete any of the objects that have been allocated. But after line 16, you do call L.father is null, mother is null, and planet is null. So look at call L, you delete the mother, you delete the father, and you delete the planet. Okay. So let's just keep it like that. This is for line 19. When you reach line 19, this would be the object diagram. And of course, I'm doing something wrong here because I said this is line 12. This should be line 19. Okay. Line 19, what you have is you still have the same stack allocations. So this part has not changed. What has changed is what is being pointed to, what is stored in the variables that are in the stack. Now Krypton is null, Jor-El is null, Lara is null, and there are a bunch of things on the heap. Only 2 things are reachable, person 3 and planet 2. Planet 2 is Earth, person 3 is Superman. Only these 2 things are reachable. This part of memory is not reachable. So you will not be wrong if you said that a garbage collection will take care of this. It will remove all this and we can completely take it away. But I'm not going to remove it because usually garbage collection works by checking for objects that are unreachable. So that is objects that do not have any arrow marks pointing on them. Here you have a cycle. So person 1 points to person 2, person 2 points to person 1. So you have a cycle, and it's hard for garbage collection to detect this and remove all these 3 allocations. Right. So when you want to delete person 1, you look at it, and you'll think that, okay, person 2 is pointing to it, so I can't delete it. But when you look at person 2, you'll if you forget everything else, you will see that there is an incoming arrow mark from person 1. So you can't delete person 2 either. Because you can't delete person 1 or person 2, you cannot delete planet 1 either. But again, for this course, at this point of time, we don't care much about garbage collection. So you won't be wrong if you just remove this big code, this big allocation. Okay. Anyhow, you have Clark Kent. You deleted Krypton, you have Clark Kent, and you have planet Earth. Okay, what happens next in the Superman story? Next, what happens is line 20. You set Kal-El's planet to Earth. So let's do that. So this is planet, that is Earth. And now you have to do 2 more allocations. One is Jonathan Kent. So I'm going to just call it person 4. So let's just call it person 4. Maybe it's easier to allocate here, less cluttered. So allocate it here, person 4. That is Jonathan Kent. Person 5 is Martha Kent. Of course, you have both of their planets are Earth. Lines 26 and 27, you have said that both of them are spouses of each other. Okay. And now something interesting happens. Now you alias the next line, which is line 28. So I'll highlight it here. You say that Clark Kent is Kal-El. So in the stack, what you're doing is you look at where Clark Kent is and you point there. Now, if you do Clark Kent dot father is Jonathan Kent, you're actually doing person 3 dot father is Jonathan Kent. So to draw a solid line here, it's father. See, so in Krypton you used Clark. What did you use? Kal-El, and on Earth you call the same person as Clark Kent. So I'm just going to call this mother, and you destroy the identity Kal-El. Okay, so in line 31, you do this by setting Kal-El to null. Okay? You don't do something like delete Kal-El, you set Kal-El to null. So we just remove this little arrow, and even if garbage collection were to run right now, it won't delete person 3 because Clark Kent is already pointing towards it. See, so it will not, garbage collection will not get rid of person 3. At this point, the object diagram will look like this, and almost like this, except PC is now line 31, 32. Okay, And our final object diagram is at line 35. Now the only thing that you do is you create Superman and assign it Clark Kent. So Superman, you alias with Clark Kent. Okay, so now if you look at Superman, his father is person 4, which is Jonathan Kent. Let me just do that. If you look at Superman, he's pointing to person 3, whose father is person 4, which is stored in Jonathan Kent. His mother is person 5, which is stored in MK, which was Martha Kent. Yeah. And his planet is person 3's planet, which we have earlier set it to Earth. So planet 2 is being pointed to by Earth, and none of them get removed. Okay, so that was it about the first program. We looked at a large example, something like 30 lines of code, and we drew all the allocations, and we saw how all the pointers change when we we saw how all the pointers change when we deallocate stuff. Okay, so this was a bit long and maybe a bit boring. The next example in the notes is quite interesting. This is example in page 19, where the wild things are. So before we draw the object diagram, let's just look at the code. Let me just create a new note here. Okay. Okay, where the wild things are. Okay, before we draw it, let's just look at what we have to allocate. So we are probably going to execute this main method first, and it has an argument, args, and the local variables are mother, max, and then max and wolf suit. And then you actually do something very interesting, which is call a procedure. And then there is no more allocations. Okay, what happens in the procedure? You have this procedure sail away, and it also takes as argument a person P. And you have an array of wild things. The array actually contains 3 wild things. What else do you do? So you kind of roar, gnash, and claw with the wild things. And then you have this person king as P. And this will be interesting. The compiler would have to look at this and say that, okay, this is a literal string, and I need to the compiler would need to allocate it before the program executes. Similarly here, so a lot of strings. Yeah. Okay. Many more strings, but that's it. We don't have anything else. And we have 2 other classes to represent wild things and persons. And finally, you have a cursive call to sail away. So if we will execute it, then we'll have to look at what happens in the recursive call. Let me just pause this for us. Yeah. Okay, so let's start with the object diagram for this. In the notes, we have drawn the object diagram at PCs 32. So let's do the same here. Here's 32. Before we reach 32, you have to execute main, and local variables in main were the mother, max, and max in wolf suit. Okay. The first thing that you do is you allocate a new person. Let's just call it P1, would be the mother. Now you have Max, who is P2. Max is, has one of this. Max has one of its arguments as true, but we are not going to represent that here. We will make use of it though. And finally, you do aliasing. You say max in wolf floating as max. Okay. So at line 6 in the program, we have to do mother.say while things, which means that you actually the compiler will have to do allocate a string. You'll have to call it while things. But that's it. There is nothing that is pointing to it. You'll just print it and then you'll just forget it. So if you are going to draw an object diagram for this method, which is .say, so you'll have to look at what it means to say things. That is line 43. So say is system.out.println. So you'll have to make another stack call, say, and somehow, so say does not do any allocation. It just has S, and S is pointing to while things. Oops. S is pointing to while things. Then you'll have to make a system call, which is system.out.println, that we can't show in system in our object diagrams. So this would be what I would draw as an object diagram at line 43. Okay, and that is not the purpose of this particular example. So I'm not going to draw all the strings here. Okay. There are a bunch of strings, but I'm not going to show any of them because they are all just printed and then forgotten. Line 7, again, Max in wolf suit says, I will eat you up. Okay, again, you have to allocate a string, print it out, and then forget the string. And now the interesting thing happens, which is you'll call sail away at line 8. Let's look at sail away. So I'm just going to denote this as a method. So this is sail away method. And it takes a person P as an argument. Oh, one more thing, you had this for your main, you had string args. Even though it was not used, it has to be allocated. So you should have something in the stack that should say args. Okay, so for sail away, you had this one argument, person P, and we said you have while things. Again, even though it's an array, it is in the object diagram, you just treat it as a normal variable because we don't care about types. And then probably we'll have king, person king at line 19. A bunch of things. That's all the local variables you have in sail away. And let's see what happens in the function. In our current execution, you call sail away with max and full suit, right? So line 8 says call sail away with max and full suit. So what does that mean? It means that our person is P2. Okay, and you set in line 13, you set is lonely to true. Okay, again, we're not going to represent that here. And in line 14, something interesting happens. You allocate a lot of things in line 14. You have this new array, and you have 1, 2, 3 objects in this array. Okay, so the way you represent that is you have while things 1, you have while things 2, while things 3, and you have an array 1, and the array 1 somehow points to all 3 of them, and while things dotted arrow points to array 1. Okay, so all these things happen at line 14 in your code. And line 16, you do source, nash, and clause. Sorry, line 17, you do all these 3 things. And you look at what those things are. They're just void methods. They don't do anything. Okay, so we execute them, no allocation, nothing. Okay, and now the next question is line 18. What happens at line 18? So can P stare without blinking? Okay, can it? Well, you have to look at P. So P is P2. P2 is max. So let's look at the code. When we were allocating max, the first argument was true and the second argument was false. So in the constructor for the class person, we have the first argument is blink and the second argument is lonely. So can stare without blinking is blink. So P can stare without blinking. Okay, so line 19, you will get rid of then branch or the else branch. So in line 19, you make another alias, which is you make king the P. And you have line 20, you have king dot say be still. You again have to do the string allocation, but I'm not going to show it here. King says a bunch of stuff. Oops. Yeah, you do rumpus. And for each of the while things, you do the same thing. And the king says star. Now the next question is king lonely? We did set is lonely to true at some point. At line 13, we did set is lonely to true. So yeah, the king is lonely. So again, you say a lot of things and you make a conversation. And again, while things does a lot of stuff. while all these are interesting, they're not going to show up in the object diagrams because they are all temporary allocations, and the garbage collection, we just assume that the garbage collection removes them. Or they are void functions, in which case we don't have to do anything. Okay, after that, you reach line 32 and you return. So our PC is at line 32. Yeah, so this is our object diagram. That is our second example. Yeah, I forgot one crucial thing, which was that sail away was being called from main. So in your stack trace, you have to start with main, and then you have to draw an arrow mark that connects main to sail away. Okay, that is good. So we are done with two of our examples. Now for the third one, I think the professor already looked at mutation and aliasing with linked list, immutable list, and I think he just briefly touched on what the final keyword means. So the final keyword is one way to say that you cannot reassign a variable. You can only assign them once, and that's it. You cannot change what it's being pointed. You cannot change what it is being pointed to. You can change the variable itself, but you cannot reassign it and change it to a different variable. Okay, so for this example, let me just quickly create a new node. Okay. In this example is mostly to show you what final is and how the compiler figure out how the compiler enforces this rule of being final. So before we draw the object diagram, we just look at the class. You have this class final and you have this class C. Class C has the string F that is declared as a final string. And of course, if it's a final string, you'll have to initialize it in the constructor, otherwise you cannot initialize it. And that's what the constructor does. It also takes as argument a final string. So in this context, what your meaning is that you're not going to change it. Not going to change it. Okay, you have this method main. Method main has first local variable final string s and final string message, and it takes a bunch of arguments, and you construct a final object C, and then you print something in the command line. Okay. So let's see how that will look in our object diagram. Before we draw the object diagram, is this program correct? Will this compile? Well, the only reason it may not compile is if you're changing final variables. So let's look at whether we are doing that. So at line 7, you have a final string message. Line 8, you're doing one allocation. And line 9, we are doing another allocation. That is okay because it's an if then else branch and only one of them gets executed. So you're not reallocating message. It's either the if condition that is executed or the else condition that is executed. So you are in fact only doing one assignment message. So that is okay. The compiler will not complain. And then the next thing is you assign C to a new object, the message. That is also fine. And then you print it out. So everything looks okay to me. So let's draw the object diagram at the 11th line, just when you print things. You obviously have to call this main method, and it is args. It has local variables s, message, c. That's it. Okay. So now you have a string known that is stored in s. That's what line 4 does. And so let's just assume that args.length is 0. So you have to pick one execution. You will have to either yeah, you'll have to either choose line 8 or line 9. Let's just go with line 8. And you go with line 8. You have string no args that is stored in message. And again, line 9 is not executed. And finally, you have C is in new object. So let's just call it C1. And we have message. So C1 has as one of its fields, the final string. It is found no args. Obviously, C points to C1. So that's it. That is all there is to it for this example. The main thing here again was that you use the final keyword. So you have to check whether your code compiles before you start drawing the object diagram. Let's try this bogus example and see why it won't compile. In the bogus example, you have this method main and you declare a final string s. And then you try to redeclare it. So the compiler will immediately catch this and will say, no, this is not large. Okay, so that's it for this week's tutorial. We went over 3 examples and we drew object diagrams for them. The first example was a story of Superman. It was a long example. It had a bunch of aliasing and setting things to null and removing things because of garbage collection. The second example was a story about wild things, and it had a function call. That is what the interesting part of it was. And the third example had this final keyword. You have to be careful to check whether the code actually compiles before drawing an object diagram for it. Thank you.